So today is another repair video. See what I got. Is a clothes iron, okay, and it doesn't work at all. They said although they connected to the electricity, but it doesn't work, doesn't function. So let's see what we can do and how we can repair this guy. Let's do it. Okay guys, so let's have a closer look on this device. As we said, is a clothes iron, okay? So this is the iron over the steam will come out, okay? Need to fill up this container with water and we'll convert it into a steam, and this one to hang the clothes that will be connected here. Okay, so let's come close to it. So if you see here, from front, got some controller to control the temperature, and also there's an indicator to indicate there's electricity come to the device. Okay, we already put in the electricity plug, but there's nothing there. So before we dismantle it, I expect to see, actually I didn't expect to see much there, just a heater to convert the water into steam, and also need some thermal control circuit to control the temperature. That's been following the selector. So hopefully it got some issue that's still be able to be fixed. So yeah, let's go ahead and try to dismantle it and see what's happened to this poor guy. So at the beginning, let's try to take off this one. This one we don't need it. We put it aside first, and also try to disconnect this hose. I believe it should be disconnected from, because this one is rotating, but it doesn't look like it's come out easily. It looks like there's a lock has been released. Let's see, it looks like stuck somewhere. It's okay, let's keep this first. Let's take out this. This is a water container. Put it aside also. Now let's come to this guy here. Have a closer look. Yeah, it looks like this way it's locked and this way is released. Maybe need a harder pull. Yeah, here we go. You see, it looks like it's stuck. Got the O-ring here. Okay, O-ring looks nice. Looks second piece here. So this one both side. What else could be taken off from here? Okay. So this one, I don't know what is this. See if you can open it. Cannot. I guess we need a screwdriver to undo these screws so we can access to the circuits inside, so we can do some testing and we see what we can do. Okay guys, so here we go. I prepare my screwdriver. Let's start dismantle it and let's see what's issue with this device. Okay, so here we have some screws, need to undo it. There's one. Looks like this device been opened for the first time. We can feel this another one here. Here we have another about 6 screws. Okay. There's a 4. Okay, and 2 here. is being open already. I guess need to take out this one. Need to pull it off or somehow. Oh shit. Looks like we broke it. Let's see what's inside. Okay. Whoa. This looks kind of dirty. Okay. So this is the base. And this one they put something heavy to keep it on the floor. This is what's inside. Yeah, exactly what we expect before. This is the power source come from here. This is the heater. You can see it's full of what they call the salt. The salt being accumulated. Okay, full of scales. Okay, so this is the heater. The water comes from here. There's a container here. The water comes from here to the heater. Heater increase the temperature very high until it becomes steam. Then the steam come out from this hole and go to the device or to the jig that used to iron the clothes. Okay, so this is the heater here. You can see from here this is the two inputs or the 2 points of the heater. This one and this one, these two. Here we have a thermal protection to cut off, I believe, the power, yeah, in case that this auto doesn't work. So this one could be cut, I believe. Another one got maybe a resistor, thermal resistor there, the one down there. Yeah, that's all. And this is the control where we can control the temperature. But I can't see how it's control the temperature. Got no feedback, got no sensor. I don't know how this works. So I believe this one is just scam. I'm not sure how they can control the temperature. I believe the temperature is fixed. Maybe got only two levels, because here we have the diode, either full will be continuous supply the current to the heater, or will pass through the diode, so the diode will be, because of the V diode, so it will be reduce the input. Could be, or maybe, oh no, sorry, because we have the diode here, so it will act as a half-wave rectifier, so actually it will drop the input into half. This PV diode, it will drop, yes. So here, yeah, I can say, I will double check later with the multimeter. This one I can say, from the first glance I can say, is only got 2 speeds, although here they show about like 10 speed, but I don't think so, got 10. This one got only two levels, I can say. The full level, whereby the power directly go to the thermal cutout, to the heater. The second one is go through the diode, whereby the diode act as a half-wave rectifier. Half-wave, you just divide the V in by 2, which is instead of 220, it will supply or reach here only 110, which is half of the power. Okay, no problem. Looks. So now I'll bring the multimeter, then we try to check the continuity of the wires and see where's the issue. Okay, let's continue. Let's go and bring the multimeter. Guys, it's very quick update. Before we go bring the multimeter, I just want to teach you a trick. These screws, the one we take off just now, we took off, it's better to put back on the holes or on the place, otherwise we might lose it. Because you know, sometimes we might take very long time to continue with this repair, so it's better to put it back in the place so we won't lose them, because you know this screw is easy to be lost. Okay, so I'll put back in the holes before I move on, because I just remember my multimeter not here, is in the office, so it might take some time to bring it back home. So yeah. So that's why it might be this device lay down here and there for quite some time before I bring my tools. So let's put back this here, and now we are ready to keep it aside waiting for the multimeter to continue troubleshooting the device. Okay, so here it is. I brought my multimeter and I use this crocodile clip for easy measurement, and you see I set it on the buzzer or the continuity test. So I will buzz the head of the connector of the socket of the wire to the terminals here and see if there's a continuity or not. Okay, so let's start with this one. So this one, as we can see here, there are 3 wires. Green mostly is ground, that will go to the chassis. And we have red and blue. So let's start with the blue. We follow the money, we go here. The blue's there. There we go. You can hear there is a there's a buzzer. So the first one is okay. Now we test the second one. So now we test the blue. Then we need to change to the red one. Red one go there to the resistor, then go there to here. Interesting. Here we go. This one go no signal at all. Could be a cut anywhere. This all looks fine to me. And again, this one got no signal. This one blue. This one looks like got no signal at all. Oh, here we go. Well, see, looks like someone stepped on it. If you see, looks like someone stepped on it and this pin is broke internally. You see? Wow. Looks like it's easy fix. Okay. From the first glance, doesn't look like it's broken, but actually got internal broke. Let's see if we can make it work by pushing it kinda hard. Let's see if the one is still working. I'm sorry if that was out of the camera. Yeah, I hear it once. Yes, see? If I push it hard, it works. So confirm. This one need to be changed. Okay. I'll find a replacement for this plug, then I will replace it. So now let's check the rest of the heater or of the iron. So again, here we have just a thermal switch, where there is some certain thermal that will be cut. It will cut off the current. So this is the heater. Should be connected. Yes, it means it still function because it's just a coil inside at the end of the day. This one again should be connected because if it's cold, should be connected or should be short. When it's overheated, then it will be open the circuit or become like open switch. What else? What else we should check? Oh yeah, let's check the switch. Let's check the switch. So we put one, let's say here. Since this wire go to the thermal switch go to here. So this is one end, and we test the other end. The other end go, let's say here. You see now. I'll try to turn off. There we go. Now it's off, or at number 1, maybe. I'm not sure which level is this. Is rip off. So 1. You see exactly what expected. So when the level is 1, 2, still the same, 3, 4, 5, 6, 7, 8, 9. This one always connected. Oh no, sorry, now is off. Now is on. Interesting. Hold on, If I connect now to the second one, 2, 3, 4, 5, 6. Oh, interesting. Looks like this line of diode, it's always on. Okay, you see now it's off. 1, 2, 3, 4, 5. All the levels, they are on. But if I connect to the other one, 1, 2, 3, 4, 5, 6. After 6, then this diode will be connected. Interesting. So it means they are just adding diode in the between to reduce the power or the power of all of the sine wave, because this one 220 from the AC. So the sine wave, if we use a way what they call the half wave rectifier, definitely the power will be almost half. Yeah. So this one again is just a normal diode. I believe we can measure it. Yeah, so this one open. Now we can measure again on the other side. Here we go. 528 millivolt. This is the feed forward. And if we flip it, give us open. So just a diode. So now if we measure the resistance, let's start with 20K. Let's see if the resistance kind of changed if we change the range switch. Let's put it here. Nope. It's not changed at all. Let's go down to 2K. Actually, there is a resistance change. Actually, oh no. Still 4, 5. Go down. 4, 5, 5. Whatever we go. Only when we turn off. Now turn off. Open circuit. 1. Now the resistance is low. Now we can see some resistance. I go to here. Let's see, this is the maximum. It shows 0.04. 0.05. No. I don't think it's a resistor. No, it's not a resistor. I guess just a loosey connection just now. See? Yeah, so this is just a switch. No variable resistor, no nothing. So all these, they are fake. It's a fake range. It just let, let's say from 1 until 5. Okay, from 1 till 5, or the low range will be going through the diode, act as a half wave. Sorry. Act as a half wave rectifier. Okay, to reduce the power. And after 6, it will bypass the diode and put the full load directly to the heater to run it at the full load. That's all. So I don't see any thermal controlled or really a real stage or steps to increase the heat. Yeah, so that's all. So now I will try to find a replacement to this plug. I will cut it out, find another plug and change this head. Okay? Let's find it. Okay, so I already found this plug from my toolbox. So now I'm going to replace this old one, the broken one. I will cut it, then I'll replace it with this guy. Okay? So here I bring the cutter, cut it out. Now I start to see, I cut it too much, and if you can see here, let me zoom. I broke the wires, or the insulator of the wires. See? So this is wrong. I'll cut again, Then I'll try another one, but this time I'll try not to press too hard. There we go. Okay, so these are the 3 wires. Take out the insulators. Okay, this is 1. This is 2. Then 3 ground. Okay, so now we will do very fast check. Power this, go to the continuity, just to make sure that the rest of the wire is okay. So we take this one, and the other end is here. We just disconnect it from here. Okay, so these 2. First, let's go and check the ground. So ground should be here. Yes. See? Give us nice and stable. The rest shouldn't have any continuity. And check with the blue. Blue should come to here, and at the same time she should go to the red. Yeah, because it's just closed circuit. Actually, even if you check now, it should give closed circuit because the heater already connected. So now I'll try to reduce. See, now it is going through the diode. Now it's passing the diode. You see now. Okay, this is 0. This is the diode area. 1, 2, 3, 4, 5, 6 is direct. So after 6, it direct connect the power. So that's why we can see a full buzzer. This all will be full. Then when you go below 5, it's act like halfway. That's the power go through the halfway rectifier or this diode. Okay, so now we can say the wire is okay and still function. Now I'll open this and try to connect it to the wire. Okay, so here we have the ground line and the neutral. Okay, something like this. So I will do this off the camera because it's not easy for me to do it. Then I will show you after it's finished. Okay. Okay, so here already done. As you can see here, let me focus it. So here we have the line, neutral, and the line, neutral, and the ground. Okay, so I'm ready to close it now. Yes, let's try again one more time. So take the neutral. Yeah, here, right here. You have no connection. Let's try again. So neutral go from here to here to here. One of these. Yes, here we go. You see, give us buzzer, I believe, because it's off. That's why. Yes, now we can see it's connected everywhere. So now we can. Here we have the buzzer, and even here we have buzzer. But shouldn't have any buzzer with the ground. Yes, and neutral. The line also should have with this guy. Yes. Okay, so now we're done with this. I believe now we're ready to test it with the electricity. Let's go. Guys, so I already bring my power extension and connect the iron to it, and as we can see here, it's already off. The light is off, and here also I connect my multimeter to the volt AC. Okay, need to change this to AC volt. As you can see here, it's AC now, and I put the voltmeter at the at the what they call the heater wires. So you can see here this is 0 volt because not on. Okay, so now I will power it on. Okay, we still see 0 volt, 0, because we didn't turn on the switch. Okay, so now I'll turn on the switch, but I will not turn on for a long time because got no water. So I believe that the heater will be hot very fast. Okay, so I will just keep it on for a few seconds, and you need to notice or observe the readings here. So here we go. You see 120 only, or 140. I'll off now. Okay, so this 120 is mean because this is the first 5 levels. The first 5 levels will go through the diode, as we say, half wave rectifier. So give you half of the 220, which is about plus minus 124 volts. Okay, so I will disconnect it from my power supply, and I will check the temperature. Yeah, it's hot. Okay, again, put it in, turn on, and I will try again. Here we go. The LED is on, and the reading is about 124, not 200. Okay, because of the diode, because we have the diode. Okay, so with this, I'm happy with this result. Everything seems to be work normal. This one, wow, very hot now. Like you can imagine how hot it is. This. So I'll try to put back the base together. Then we finish it already. Okay. But again, I just want to note something, guys. This job is very, very dangerous. We are working with AC volts. Okay, so please be very, very extra double trouble careful. If you are not expert, please don't touch this. Don't try to repair it, because now you're working with AC voltage. It's very dangerous and it is a killer. Okay, if you're not experienced with this, please send it to the professionals. They know what to do. Otherwise, please don't touch. Okay. Okay, guys, so now I will put everything back together. So first of all, I will take out this multimeter. We don't need it anymore. Okay, I'll put it aside first. And also these things, we don't need it. Put it aside. Okay, now I need to undo the screw. Make sure it's not plugged in the electricity. Then we undo all the screws we done before. Okay. It's true. Now we just double check, make sure everything is okay. This one off. This one I guess we don't need, because this I can see is already stuck. This one first time was here. I guess this one for cleaning or some other purpose, so this one no need, just put aside. Now we're ready to put back this, but I believe, I'm not sure if we should clean it or no, but it's okay for the time being. I will put back the cover and test it out. If it's okay function, then it's worth to be clean. Okay, so we put back the wire. Again, be careful, there's a groove here for the main wire to be going like this. Then this one will go to the top. Yes, just like this. Okay. Everything's inside. Now I need to do the screw again. Yeah, I get used to this already. I need to do the screw like cross. Okay. So it will take all the tension of the plastic or any other covers. This is a good practice actually, especially if you work on hard materials like aluminium or cast iron. Okay, so make sure everything is what is this? Okay, we're ready to go. So now our iron is ready. I will fill up the container. This container need to be filled with water. Then I'll put it here. Then we turn it on, then we see how it goes. Okay? So the container full of water already. So now we can see the water is go inside. So now we're ready to power up and see how it works. Okay, now I will attach the hose where the steam should come from. Okay, this one should be here. Yes, like this. Make sure it's off. Okay, so be very careful guys, especially when you work with the main AC. It's very dangerous. Again, I want to warn you. I already connect to the AC, turn on the electricity, so let's test it out now. So turn on this. I can see the red LED is working, but nothing yet. Maybe it's heating up. Nothing come out yet. I'm not sure, should we wait for how long to get the steam out? Nothing yet. Let me double check. Yeah, let's turn on again. I can feel the hose is getting hot. Let's give it some time. Yeah, this one getting hotter. I can see it takes water also more. Waiting for the steam to come out. Yeah, here it is. Haha! The steam is coming. Yeah, if you can see here, the steam is coming. Good, that's mean we fix it. I can see the steam. There we go. Okay, so now we can use it on our shirts. Okay, so on the send off. So I believe with this we already fixed it and we done the machine. This one become very hot. Okay guys, so I guess this is the end of our video. I hope you have learned something new, how to fix the solder iron, actually, the close iron, not the solder iron. So it was very fast and easy fix, straightforward. The issue was only with the plug. The plug was broken. Let me show you the old one. Okay, this is the old one. I believe somebody might be step on it and broke this lid. That's why it doesn't work at the beginning. So we open it, we troubleshoot it, then we find out the issue, then we replace it with this one. Now it's ready to be used again. Okay, so I hope you have learned something, and please make sure you take the full protection with full precaution whenever you work with the main AC. It's dangerous and is not it's not easy to do if you're not professional. So please pay attention to this thing. Okay, thanks.